Alright guys, today's topic is on magnetic flux. Now what is a magnetic flux? It's not a new word that you're hearing for the first time. We've been coming across this word magnetic flux in physics, so I'm going to explain for you what is magnetic flux and both the concept of magnetic flux. So simple. A magnetic flux is the measure of total magnetic field passing through a given surface area. I take it again. A magnetic flux is a measure of total magnetic field passing through a given surface area. And then to explain it further, you can say that it tells how much magnetic field flows through that surface or a particular surface. Next, we have types of magnetic flux. Basically, we have three types of magnetic flux, which are positive magnetic flux, negative magnetic flux, and zero magnetic flux. Positive, negative, and zero magnetic flux. Now let's go back to the first one, which is positive magnetic flux and how it takes place, how it occurs. Now in positive magnetic flux, this occurs when the magnetic field line pass outward through the surface in a chosen direction. It occurs when a magnetic field line passes outward, not inward, not even in the opposite direction. This one passes outward through a surface in a chosen, then also in a chosen word, in a chosen direction. So secondly, in the negative magnetic flux, this one happens when the field lines pass in what? Opposite direction. This is when this one takes place. It happens when, or it occurs when the magnetic field line passes in the opposite direction. And lastly, which is the zero magnetic flux, this one occurs when magnetic field line passes, or let not say passes, when magnetic field line cross the surface, or sometimes in a parallel direction. That's when this one happens. That's when this one takes place. Now let's look into factors that affect magnetic flux. Factors that do affect magnetic flux. Now magnetic flux depends on these three factors that I'm going to list for you. Now first is magnetic field strength. That's the first one. Second is area of the surface. Third is angle of inclination. I said first is magnetic field strength. Second is area of the surface. And then lastly is the angle of inclination. Now for magnetic field strength, it is represented with a letter B, but in capital letter B. That's for magnetic field strength. Now for area of surface, it is always represented with a capital letter A. Now for the area of inclination, you can take your mind back when I taught you guys on projector. It's always like a theta. That's the symbol. So, angle of inclination is simply what? Theta. Angle of inclination is simply theta. So you take your mind back when I taught you on projector. Okay, and also application of magnetic flux. Magnetic flux is important in electric generators. That's number one. Number two, is important in electric cars. Is important in transformer. Number three, transformer. Number four, inductors and coils. Number five, electromagnetic induction devices. Number six, power generation system. Then the SI unit of magnetic flux is Weber, W-E-B-E-R, Weber, W-E-B-E-R, represented with the letter capital letter W and then small letter B. You just write it one. Just write it, join it together. Capital letter W, small letter B. That's the SI unit of magnetic flux. So your assignment, guys, for this topic. Now I'm just giving out two assignment, but try to do your best in it and study further than that. Study it further than that. That's the main primary aim of giving you assignment, for you to study and research. So number one is according to Michael Faraday's law of electromagnetic induction, state the importance of magnetic flux. I repeat, number one is according to Michael Faraday's law of electromagnetic induction, state the importance of magnetic flux. Simple. Then number two, state the mathematical expression of magnetic flux.
Quiz.